Hi, welcome to ACE Teachers Online, a series of online tutorials for students. My name is Justin, and today we'll be going through a question on empirical formula and percentage composition. The single most important concept in chemistry is the mole concept. So what is a mole? A mole is a very, very large number that chemists use in order to quantify amounts of substances. Exactly, it's 6.022 times 10 to the 23. So it's a very big number, and we also call this Avogadro's number. It is defined as the number of atoms in exactly 12 grams of carbon-12. The reason we use such a big number is so we don't have to count individual atoms in reactions. On the periodic table, you'll see elements, and underneath them, you'll see these numbers. So what these numbers mean is that a mole of atoms of that element will weigh that number in grams. So we can use the mole concept in order to understand what percentage composition is. Percentage composition is the percentage by mass of each element in a compound. So for example, carbon monoxide has 1 carbon and 1 oxygen. So that would be 1-to-1 atomic ratio. But they do not have a 50-50 mass ratio because each atom of oxygen weighs more than each atom of carbon. So we can use this idea of percentage composition to help us find empirical formula. What empirical formula is, it is the simplest whole number ratio of elements in a compound. For example, let's take N2H4, which is hydrazine. The empirical formula of N2H4 is NH2, because there is 1 nitrogen atom for every 2 hydrogen atoms. In fact, we use empirical formula to describe ionic lattices as well. So ionic lattices do not have molecules. In fact, they're an infinite array of repeating ions. So therefore, there really isn't a simple unit you can use to describe what an ionic lattice is. Therefore, we use the empirical formula. So for example, in sodium chloride, which is table salt, we say the empirical formula is NaCl, which means there is 1 atom, or 1 sodium ion, for every chloride ion. In this compound, we have 52.1% carbon and 34.7% oxygen. We know this organic compound is composed of carbon, hydrogen, and oxygen. Our first step is to find the mass of each constituent element in 100 grams of this compound. So for carbon, 52.1% of 100 grams is 52.1. For oxygen, 34.7% is 34.7 grams. So that means by subtraction, 100 minus 52.1 minus 34.7 must give us the value for the mass of hydrogen atoms. In this case, it's equal to 13.2 grams. Now this is just the masses of each constituent element. To find the empirical formula, what we need to do is to find the number of moles. So that means we have to divide by the molar mass of each element. So 52.1 grams, we have to divide this by the molar mass of carbon, which is 12.01 on your periodic table. This gives us 4.33805. For hydrogen, we have to divide by the molar mass of hydrogen, which is 1.008. This gives us 13.0952. Now we have to do the same for oxygen, so that means we have to divide by 16. Now at this stage, we've got the number of moles of each constituent element in 100 grams of this organic compound. To find the simplest ratio in moles, we have to divide by the smallest number of moles of any element. In this case, it's for oxygen, and the number is 2.16875. So dividing by this number will get us the smallest integer ratios. Sometimes these numbers here won't be integers, but they'll be very close to, let's say, halfway between integers, or 1/3 of the way. So then after that, you can do some more manipulations to get them into the simplest whole number ratio. Fortunately for us, they are very close to integers. So this number here is very close to 2. 6.038 is very close to 6, and 1 is 1. So therefore, we can say that the empirical formula of this compound is C2H6O, and that is our final answer. So in today's video, we've briefly covered the mole concept, and then we've done a question on percentage composition and empirical formula. The most important thing about solving these questions is to first assume there's 100 grams of the compound and then find the masses of each element, then divide by the molar mass to find the number of moles of each element, and then divide by the smallest amount of moles in order to find the integer ratio. That will give you the empirical formula.
Thanks for watching this video. For more information, look at our website down below and keep tuned for more ACE Teachers Online.